Hi, today we're going to talk about how to solve exponential equations that have like bases. So our main idea here is if you have a base to a power m equals to the same base to the power n, then the two exponents must equal each other. That's the only way it's going to work. Okay? So we are going to work under this assumption. Every problem we are going to do is going to rely on that concept. So how do we apply it? Let's start with some basic problems. So we have 2 to the power x minus 3 equals 2 to the power 4. You can clearly see that you have the same base. So then the exponents must equal each other. So you're going to write x minus 3 equals 4. And it's a very simple equation. X equals 7, and we are done. Okay. The second example, same idea. You have the same base, 3 and 3. We make the exponents equal. 2x equals negative 5, and x equals negative 5 halves. Alright, so that's as far as the basic ones. What we have now is we're going to look at the equations where it's not going to be as straightforward. Take a look at these problems. So we have 5 to the power 2x equals 625. So we don't see base 5 here. However, you may remember that if you raise 5 to the power 4, you may not necessarily remember that, but you may figure it out. So then we can rewrite that as 5 to the power 2x equals 5 to the power of 4. And now we follow the same process. So basically the only thing that you're going to do here that's going to be extra is you need to figure out if you have a number, what exponent is that number going to be using the same base that you have on the other side. Example 4, you have 4 to the power x plus 4 equals 1 over 16. So it may look a little tricky, but every time we see a reciprocal, that means we have a negative exponent. So this is 4 to the power x plus 4. We know that 4 squared is 16. So 4 to the negative second power will be 1 over 16. And then you get x plus 4 equals negative 2. X equals negative 6. Example 5, 3 to the power x, 3 to the power 2x plus 1 equals 81. So we can figure out that 81 is 3 to the 4th power. So 3 to the power x plus 2x plus 1 equals 3 to the 4th. 2x plus 1 equals 4. 2x equals 3. X equals 3 halves. A few more examples. 7 to the power x minus 6 equals 343. So 7 is not as a familiar base as like 2 and 3 and even 5 are. But you can figure it out if you play with numbers. If you raise 7 to the 3rd power, you will get 343. So that means we can rewrite this side. This side is going to be 7 to the power x minus 6. And this side is going to be 7 to the 3rd. X minus 6 equals 3, x equals 9. And number 7 may look a little bit tricky. How can we connect 25 and 5? Well, if you remember that 5 squared is 25, then the square root of 25 is going to give you 5. Because remember, we want to have 25 here. Now that means we can rewrite that as 25 to the power x plus 2 equals 25 to the power 1 half. Power 1 half represents square root. Let's make this side note here. The square root of 25 can be written as in an exponential form as x to the power 1 half, because remember, we need the same base. So from here we can set the exponents equal to each other. And we're going to get x equals 1 half minus 2. Which is going to give us negative 3 halves. Okay. Example number 8. is a fairly common thing. You have to remember that any number to the power 0 will give you 1. This is an important thing that you should know already, since you have been working with exponential expressions. So we can rewrite that using absolutely any base you want. B can be any positive number, including 6. So what we are going to do is we're going to write 6 to the power 2x plus 5 equals 6 to the power 0. Then 2x plus 5 equals 0. 2x equals negative 5. X equals negative 5 halves. And so far it's all very simple. There's really no trick. The hardest thing that you have to do for these problems is try to figure out the exponents of a particular base. And with the calculator in your hands, you can do it. Even without a calculator, it can still be done pretty easily. I have a couple more examples here that are going to address a slightly different situation. What if the bases are not going to be the same, but we already had that, but you can't even make them the same using the bases that are given to you. Take a look. We have 8 and we have 4. You can really take 8 and put it and make it into a 4 by using an exponent, at least not easily. Nor can you take 4 and raise it to some power to get 8. So what we're going to have to do for problems like this, when this is not possible, is we're going to try to see if we can tie 8 and 4 using the same base. So we can probably figure out easily that 8 can be written as 2 cubed and 4 can be written as 2 squared. So what we're going to do is we're going to replace each of those numbers, each of those bases, with those expressions. So we're going to write 2 to the third power to the power 2x, and on the right hand side we're going to write 2 to the second power to the power x minus 2. I want to remind you that when you have situations like this, the exponents are going to be multiplied, which means I'm going to have 2 to the power 6x equals 2 to the power 2 times x minus 2. Let's write it this way because you do need to either distribute this now or later. So, but now we have the same base and we can set things equal to each other. So 6x equals 2 times x minus 2. 6x equals 2x minus 4. Negative 4x equals negative 4. X equals 1. That's right? No, this is positive 4x, so it's negative 1. There we go. So the answer is negative 1. Okay. And a similar situation with number 10. We have 27 and 81. So what we can do is we can write 27 as 3 cubed. And we can write 81 as 3 to the 4th. Remember, when you do these types of problems, the base has to be the same. Okay, so we're going to rewrite that as 3 to the 3rd to the power x plus 4 equals 3 to the 4th to the power x minus 3. We multiply the exponents, so we're going to get 3 to the power 3 times x plus 4 equals 3 to the power 4 times x minus 3. After that we can set those things equal to each other. We are going to get 3 times x plus 4 equals 4 times x minus 3. Distribute 3x plus 12 equals 4x minus 12. And negative x equals negative 24. X equals 24. Okay, so when you do problems like this, again, the main principle that we're going to rely on is going to be that we need to make the exponents equal. And as long as you can do that, you are going to be perfectly fine. And that's a pretty easy process. And sometimes when you are not able to do that, you can follow this process that I just showed you by setting the bases equal to each other, and that's pretty much the whole idea behind this. Okay, if you have any questions, post them in comments. I hope this helps.